react so that I know that you can hear me. All right. Okay. And then I believe also that my face is visible as well. All right. So let's just get started. So this month's edition, we have 2 sessions, and I'll be leading the first session, which is implementing Medallion architecture with Materialized Lakeview. Now, already most of us are familiar with Medallion architecture, and if we are not, we are just going to brush around Medallion architecture briefly, and then we go into what Materialized Lakeview is, and also go into actual implementation of Materialized Lakeview. So let's get started. So today we'll cover what is Medallion architecture, like I said, then different Medallion architecture pattern that we have in Microsoft Fabric, then what are Materialized Lakeview, which is the center of the topic today. And also we are going to be looking at some of the use cases for which we can use Materialized Lakeview, and also some data quality constraints that comes with Materialized Lakeview. And then we see the SQL walkthrough of what Materialized Lakeview is, and then also the monitoring, lineage, and also governance that you have natively using Materialized Lakeview. Now, Medallion architecture is gotten from the word MEDA, and it's one of the recommended patterns within Microsoft Fabric, which follow the ACID principle, the atomicity, consistency, isolation. I've forgotten the D now, I remember. So these are the 4 principles that Medallion architecture follows, and from the word MEDA, that's how we got Medallion architecture. This architecture emphasize improving, thank you, blessing, durability. Yeah, this Medallion architecture emphasize improving data from first layer to the second and to the last layer. In some instances, people have even 4 layers for Medallion architecture, where they call it platinum layer after the gold layer. So the bronze layer is the layer that you have the data in the exact form it is. The data is stored exactly as it is coming from the source system. And then you have your silver layer, which is where you do some transformation, you do standardization of data, and also you can do enrichment as well. And then we also have the gold layer, which is the reporting layer. So as you move across these 3 layers, you improve the data quality. And one of the things you want to do at your bronze layer is that you make use of shortcuts in Microsoft Fabric. Shortcuts like you repointing your data to another environment, right? So is someone saying something? Okay, please don't forget to mute yourself. So we have the bronze layer. The data is in the format it is. Either data is in CSV, in the packet, or in a data format, or even in JSON format, structure or unstructured. The bronze layer is able to take this data. Remember, Lakehouse is a part of one lake ecosystem within Microsoft Fabric, and then it can take all manner of data. So you then start to transform at the silver layer, where you start to remove invalid records. You also tend to undo duplicates in this A layer of the architecture. And then the gold layer is the reporting layer. So that's just about it with Medallion architecture. However, in practice, people have been implementing Medallion architecture with a different pattern. One of the pattern is where you have lake houses. You are using one lake house as your bronze layer, there is another lake house as your silver layer, and then you have a third lake house as your gold layer. And each of these lake houses, sometimes they can be in the same workspace or even in different workspaces, depending on how large or complex your environment is. So in this pattern 1, you can see 2 types of sub-pattern, separate lake houses, either in the same workspace or different workspaces. Another pattern typically that you will see is you have your bronze layer and your silver layer as lake houses, and then your gold layer as a data warehouse, because a data warehouse has a richer SQL endpoint that actually allows you to use all the SQL syntaxes, as compared to lake houses that are restricted in some of the syntax. So these are the major patterns that you have. And of course, these patterns can allow you end up having different domains of data meshes. So you can have a domain that has several meshes for different business units, either for your marketing, your sales, or your business development. So these are the various deployment patterns of Medallion architecture that we have in Lakehouse. Now, we are getting gradually into materialized Lakeview, which is the subject focus for today. Materialized Lakeview is defined as the SQL transformation want, and then it presents the table as a data table in your Fabric environment. Now, remember, we just walked through the Medallion architecture, and then at each of these layers, maybe in just the bronze layer, you have your data as unstructured data, maybe as package or as CSV or as even as JSON. But by the time you start improving across these various layers, then you start to have your data in delta tables or in package formats. So when you have this, it means that your data is going to follow some ingestion pattern, right? And when you want to do this ingestion, you can either use pipeline, data flow, or even notebook. So imagine that, okay, you have your bronze layer that has been dumped with various data formats, and then you need to transform this data into your silver layer. Typically, what you will do is probably have like a notebook that actually transforms this data into your silver layer. You clean it up. Like I said earlier, you handle duplicates or invalid records. So you have a notebook that transforms your data from bronze to silver. And then you have a second notebook that also transforms it from silver into gold layer. And at the end of the day, you design a pipeline that is used to orchestrate the sequence of execution of this notebook. So in that instance, you have a lot of Fabric artifacts to manage, right? You are going to be managing notebook, you're going to be managing pipeline. You can use a pipeline if you want to orchestrate the execution of the notebook, or you can just schedule the individual notebook. Either way, you still have pipeline and orchestration logic to implement, right? And that way also you have multiple lake houses. What Materialized Lakeview is, think of it as your SQL view. You know, you can have tables, but when you know that there are some certain reports that you go back to your SQL database to query every time, you want to save those type of scripts as a view so that you can then connect to that view and use it for your reporting, right? So Materialized Lakeview is that type of view within Microsoft Fabric that allows you to use your SQL script to predefine how you want your layer to be. Imagine that in your own orchestration, you are ingesting data from source system into your bronze layer. You have a product table, you have order table. And then you need to create another table in your silver layer, which is going to be transformation or merging and joining of those two tables from the silver layer. Typically, you want to use a notebook, and then you probably want to implement some SCDs, and you do that maybe in your notebook, and then you have to write PySpark for it. But in this Materialized view, we are saying that you can use SQL scripts to predefine your silver layer and also your gold layer, such that when you implement it, it sort of pre-computes the output table and save it back onto the one lake as a delta table. Remember, when you want to do your silver layer with a notebook, typically you run your notebook and then you write your script to save it as a data table into your lake house. And that's how you have your silver set of tables, either in separate lake house or in the same lake house. But in this instance, we are saying that you are going to have just a script that is going to pre-compute your source data into your silver layer, and it's going to be executed per time, right? So it allows you to write SQL and store the definition of that data so that when you are connecting to that delta table, that data table is based off the SQL script that is computing the silver layer and consequently the gold layer. Another thing that comes with Materialized Lakeview is the fact that it has an optimal way of handling refreshes. Now, we know that when you are doing your data ingestion, there are different refresh patterns. You can have your full refresh, you can have your incremental refresh, or no refresh at all when you capture data change, right? So Materialized Lakeview also comes with its functionality that allows you to dynamically select the appropriate refresh pattern. And all of this, you can define it from the UI, right? And also, the query sort of give you a table that you connect with. Now, to implement Materialized Lakeview, all you need, of course, you know that you need your Fabric-enabled workspace, and then the lake houses that you can use to implement Materialized Lakeview has to be enabled with schema. Remember, when you create your lake house comes with a default schema, that's DBO schema. But you can also create custom schema. In that instance, you can remember that you create a lake house and you're using one lake house for your Medallion architecture. So you can have one schema for your bronze, another schema for your silver, another schema for your gold. So one of the prerequisites for implementing Materialized Lakeview is that your lake house at the point of creation must be schema enabled, as we are going to see shortly, right? And of course, the fabric runtime of your workspace is going to be fabric runtime of 1.3 and above, so which is what is required for Materialized Lakeviews. And then the source tables, they have to be in Delta table, so for incremental refresh. So, any question before I proceed? And I believe you can hear me. Or just a show of reaction if you can hear me and you are following, please. All right, thank you, Olaliko and Blessing. Yeah, Bashir and Fatah. Yeah, Mayawatu. Yeah. So remember I said that you are going to be using SQL scripts to define your various layers. For example, these are some patterns. Maybe you have a reporting that you want to do, right? And then you need to report on your sales across various regions. Then you want to know the total sales, right? So this is one. If you want to create a view in your SQL, what you typically will write is that create view as the name of the view, and then you write the SQL script that creates the view. So this is one pattern for Medallion use case. For MLV use case, rather, that's Materialized Lakeview. No notebook. So at the point of execution of the schedule refresh, then it pre-computes your data with this SQL script. Another use case is that you can use your Materialized Lakeview. There are some syntaxes that are available with Materialized Lakeview that allows you to implement data quality. For example, maybe you want to provide customer data, and then you don't want to use customer data where there is no email. Think about an example in a rewards environment where you are working in a marketing team and they want to do an email blast. And then you know already that to do that email blast, having an email column that is not null is very critical to that task at hand. So you want to ensure that every email column is populated with their email. So in this second use case, you can use Materialized Lakeview to define your data quality. And then the constraint to say that valid email, check the email column, and when there is a mismatch, you drop. So drop means that you are going to remove those records where there is no email. So that is another pattern. Another pattern is when you are trying to pre-compute several joins. You know, we have different type of join in SQL, right? You have your inner join, left join, right join, and what have you, and different type of joins. So you can also use that to pre-compute your complex pattern. And then as you are using SQL to define all of these things, you are improving your data quality from your bronze layer to silver layer and to gold layer eventually. Another thing you can use it for is that you can use it to partition large data sets so that your data is grouped. So if you look at some of these scripts closely, if you start looking at them from the select statement, you will see that this is just a simple window function, for example. And all these are just syntaxes to define the Materialized Lakeview itself. And of course, there is a constraint here that is checking if the customer name is not null. If it's not null, on mismatch, then you should drop it. And then you ensure that you have a customer table with a full customer name. Some of this type of transformation and cleanup, you implement them with your notebook typically, right? So, but you can also use your SQL script to define them even before you have them as your Delta table. If you also look at this as well, you will see that if you look at it from the select statement, it's just a simple join table between the products table of the bronze layer and also the other table of the bronze layer to create a clean order table, right? So these are some patterns that you can use with materialized Lakeview. Now, I know that some of these things might sound abstract, but once we get hands-on with materialized Lakeview, they will become clearer. I already talked about the data quality, right? So when you don't define the data quality on default, it's going to stop running, right? But once you define it that it should drop, then it's going to just drop those records that have null based on the constraint column. And then the entire script will continue to execute and create your data table for you, right? So those are some of the things that you can do with materialized Lakeview. I already talked about the constraint pattern. If you are checking for null, in this case now, the constraint is checking for null for the customer name. You can also use it to implement maybe a quality in your numeric field. Let's say you have a quantity field and then you don't want to use where it is less than 0 or you have negatives. So you can use this as well, right? This is another constraint where you want to ensure that it's only showing for a particular name, right? And you have used the substring function to define the name you want to use. Then this is another one for the email that I talked about earlier. So one of the things that you get to do, like I talked about earlier, is the optimal refresh. This optimal refresh gets to pick between the skip, incremental, and full refresh. Now, skipping is going to happen when the source table from your materialized Lakeview has not detected any change. Now, imagine you are doing a refresh of your source table, even though there is no change. Invariably, you are going to be increasing the cost of your fabric in your environment because you are just doing a refresh when there is no changes in your environment. Now, another thing you can have is the incremental refresh. This refresh will only happen when there is a change. And for this to happen, it's very important that this feature is set to true. It is called the change data field. This change data field must be enabled on the source table. The source table being the tables on your bronze layer. If you don't have this enabled and then you turn on the optimal refresh, then the incremental injection is not going to take place. So the feature has to be enabled on all of your source table. So in this one, let's say you have about 10 million records on your source table, and then the table has grew over the weekend with another 2 million records. Instead of loading the entire 12 million, then it's just going to load the 2 million new record. And imagine if you are going to be implementing that in real practice, right? You know that you need to put some logic in place, either in your pipeline or in your notebook, and you are doing some lookup activity to figure or filter where the record has changed. Maybe you are using your date column or something. But with Materialized Lakeview, there is a native feature that is able to detect that sort of change so that you don't have to manage that complex pipeline to implement incremental loading pattern. Remember, you need to enable this change data feed feature on all of your source table. And then full refresh. If you decide not to turn on the optimized refresh, then the full refresh is what is going to happen. So with Materialized Lakeview, you get to use the optimal refresh that picks between skip, incremental, and full refresh. So let's look at this SQL walkthrough, and this is what we are going to be implementing today with Materialized Lakeview. So our source system, we are going to be creating a bronze schema. Remember, one of the things that you can do with Materialized Lakeview is that you must be using a lake house that is schema enabled, right? So we are going to be creating a schema called a bronze schema. And in that schema, we are going to have two tables. We are going to have our products table and also our order table. And then we need to set this table property for this change data view to true, which we are going to see. Because at the end of the day, when we turn on our optimal refresh in Materialized Lakeview, it's able to dynamically pick either to skip a refresh, to do an incremental load, or to do a full load. Without this feature enabled, which is also going to be defined with your SQL script, you cannot dynamically pick the type of refresh you are going to be taking. Now, the two tables we have is going to have other table, other column, which is an int column, products, and then quantity, and also the other dates. Then we move into our bronze layer, because in this Medallion architecture we are going to be implementing with Materialized Lakeview, we are going to be using different schemas for our Medallion layers for the bronze, silver, and gold. And then also we have this constraint that is going to be dropping, and then it's just a simple join between the product table and the other table. Now we have a full clean order table as compared to this other table that does not even tie to the customer. And then finally, because the data points might seem like a lot, and we want to now implement the gold layer, then we now start to include some aggregation functions. You see your sum on quantity, you see the sum on revenue, and you see the average revenue as well. And then we are able to now create the gold product summary. So this product summary table is now going to be the reporting layer that we get to use. And what I think that Materialized Lakeview also has is that it's able to orchestrate from these three layers automatically, as we are going to see shortly, right? So you use your SQL to define your layers of the Medallion architecture with Materialized Lakeview. Are you following, please? All right, thank you. Then also, you have your monitoring and governance as also part of your Materialized Lakeview. The Materialized Lakeview comes with a lineage view that shows you the bronze, silver, and gold layer, and then the data quality reporting that is natively as part of the Materialized Lakeview. Typically, when you are implementing a real-world scenario, you want to have a log of records that have failed, right? So that you can go back into the source system and correct those records. Now, Materialized Lakeview has a default data quality report that is able to tell you the number of records that have failed. Maybe you had set that it should drop when you have nulls on your email column, and then you want to see the number of records that were dropped in your Materialized Lakeview that does not have email. Then from this data quality report, you are able to see that as well. And of course, you can schedule the refresh and also govern that refresh in your Materialized Lakeview. And if you want to go more fanciful, you can activate some data activator alerts on your data quality report as well. So this briefly covers Materialized Lakeview. Now we are going to head over into Fabric environment and then implement it in practice. Are you following, please? And everything I'm saying is available from the Microsoft Learn results of Materialized Lakeview. Once you go to data engineering, bits of the documentation, you're able to see what Materialized Lakeview is and everything you need to know about Materialized Lakeview. Recently, it has also been enabled for PySpark. So you can now define Materialized Lakeview also with your PySpark. But before, I think as at last month, it was just with SQL. But now you can also define it with your PySpark script as well. So let's just go into the actual implementation now, and then we see what Materialized Lakeview is in practice. All right, let me go into my Fabric environment, and then I'll bring that into our screen for us to see. All right. Now let's go back into our Fabric workspace. I think I have a workspace for the community that I use typically. Now this is a workspace, a Fabric enabled workspace. So I'm going to close this. Then I'm going to create a new lake house for this purpose, right? So I'm going to create a new item, and then I will create a lake house. Let's call this lake house underscore MLB underscore community, right? Now, one of the prerequisites I mentioned with Materialized Lakeview is that it must be schema enabled. So before, having schema in your lake houses is not a feature that was generally available. But now having schema is not generally available, and then you can decide to enable this feature at the point of creating your lake house for Medallion architecture, right? So you need to make sure that, sorry, just a moment. I'm trying to get the script we are going to be using for this implementation. Then we proceed to do our materialized Lakeview. All right. So I'm going to create this lake house now, and then I enable my my schema as a key prerequisite for that. Right. So the lake house is being created. So let's just give it a minute for the lake house to come up. Right. So when you create your lake house, you realize that now you have your home tab, and then you have your materialized Lakeview tab. So this is what your materialized Lakeview look like in Microsoft Fabric. And once you have it on your screen, to start, all you have to do is to click on Manage, and then you have this screen, you have your recent run, which we are going to explore shortly, and then the data quality report that I talked about earlier, right, is also available here. But because we have nothing here, we are not going to get anything here. So after we've created our materialized Lakeview, then we can come back and check our data quality report. So let's just go ahead. And also you can see that you have, for optimal refresh to work efficiently, enable a data CDF. CDF is change data feed property on both source table and materialized Lakeview used as source. So it is possible you use your source table as part of your architecture, or even use another materialized Lakeview as your source table, right? So either way, either you're using a source table or a materialized Lakeview as your source, this CDF property must be enabled for optimal refresh. So already you can see that this is already available for us as a notification and warning. And of course, you know that when you create a lakehouse, the SQL endpoint is also created for you as well. So what we are going to do now is that we are going to click on this new, and then you can create a new notebook. Remember I said that you can either define it with SQL. When it started, it was with Spark SQL, but now, just last month, is now being implemented also with PySpark, which is still in preview. And as you already know, you don't use a preview feature for a production workload. So let's just go ahead and create a Spark SQL notebook. So then our notebook will be created for us. Now, if you create your notebook this way, automatically the lakehouse that was created will be attached to that notebook. Or if you create your notebook independently, you can manually just add your lakehouse from the notebook interface. And of course, you can always switch the Spark you are using from here, but we are using a Spark SQL in this instance. So when you create it this way, then it sort of predefine this notebook. So let's just clean up this cell, and then let me get the script we want to use into our screen. Okay, I'll just do a control V now. So quickly, we are going to use this to create a schema for the bronze layer. Before I do that, let me expand. You see that we have a table, which is a DBO schema. But before I even run this, let's go back into our workspace and open the lakehouse itself. And this is the lakehouse. And then you can see the Explorer pane. On the Explorer pane, you have tables and files, right? And then you have a DBO schema. At the end of the day, we are going to have multiple schemas, one for each of the layer, the bronze, the silver, and the gold layer. So that is what we are going to be defining with that notebook. So let me switch back into my notebook. So I'm going to run this, and then it creates the bronze schema. So in addition to DBO, and also we are going to create a table. Now you can see that we are just saying that create a table if does not exist. Bronze.product. The name of the table is actually product, but that product table should go into the bronze schema, right? And then we have about 3 columns: the product ID, product name, and also the price. So this will create the schema and also the table. And in that table, we are going to just be inserting 3 records: the product ID, the product name, and also the pricing. And then the same thing for the others table. We insert also 3 records and the column as well. So let's just run this notebook now, and then we wait for this to be completed. Are you following? All right, thank you. Typically, you know that your notebook starts is always going to take a longer because you are just starting a new Spark session, unless you have a Spark session already running in your environment. Yeah, so our cell is done running. So before I continue, let's go back into our lake house, and then we can just refresh this table and see if that schema was created. Now you now have a bronze schema, right? With 2 tables. We have your orders table, and then you also have your product table by executing that notebook, right? So now let's go ahead and now start to create the materialized Lakeview. Imagine that you have these 2 tables as your source table, maybe by shortcut or by uploading CSV file, you have this table, or even by just connecting to an Azure SQL database or even an on-prem SQL database, you have these 2 source tables, your orders table and also your product table available. But now we are not going to be, so this is our bronze layer. We are not using these 2 tables to create our silver layer, then our gold layer eventually. So let's just go ahead and implement other parts of this. So we are going to go back into this notebook, right? And then we create a new code cell. Remember, we talked about optimal refresh, and we said that to use optimal refresh that allows you to dynamically pick if you are doing a skip of your refresh, if there is no data changes, if you are doing incremental loading pattern, or if you are doing a full refresh, you need to enable change data feed property. So we are going to enable that now, right? So I'm going to just copy the script also into this cell. Remember, normally, if you want to just adjust any feature in a table, you need to use your alter table syntax for your SQL scripts, and then the table name, and then the schema it belongs. So we are now setting this table property to enable the change data feed to be true. By default, if you don't define it, then it's going to be a false. That's the default setting. But because we know that we are going to be using the default, the optimal refresh, you need to define it on every source table. So if you have multiple tables, then you have to define it for all the tables. So in this case now, we have 2 tables here. I think we can also view our tables from here. Let me just refresh so that we can follow along. Right, so now we have our bronze. So we have others table, and then we have your product table. So product table and others table. So if I run this now, that will turn on the change data field for those 2 source tables we are using for our materialized Lakeview. So, and that is about turning that on. So our cell is done running. Now let's start to create our bronze layer and also our silver layer rather, and also our gold layer. Before we proceed, let's go into our materialized Lakeview and see what we have. So materialized Lakeview. Let me refresh this. Okay, so until we create the materialized Lakeview before we now start to see the lineage view. So let's go back into our notebook. So from our notebook now, we are going to be doing a simple join of both the product table and also the other table. So I also paste this script right here. No, I'm not copying that. So let me just delete this. Okay. Let me put this on our screen. Yeah, I think yes, this is it. So now we are going to now create the second schema, which is going to be our silver schema, and that's for the silver layer. And on that, we are now going to do some join. Remember, we already have the bronze schema. Now we are going to create the silver schema. And then after creating the schema, then you now define the table. Unlike our bronze layer where we just inserted records, the silver layer depends on the bronze layer. and then it's just a simple join. So if you pay attention from line 4 of this script, where you have your select statement, up until here, up to line 14, you see that it's just a simple join between the product table and other table, join on their product ID column. And then this other part is just to define the name of your materialized Lakeview. Just like you are creating your SQL views, right? Create materialized Lakeview if no exist, then the schema. Now, if you put silver dot, the name of the materialized Lakeview you are creating, then you are specifying the schema where that view should go into. But if you don't define silver, which is the name of the schema, then it's going to go into this default schema, which is the DBO schema. So that is why it is important that you create the schema first, if no exists, and then you now create the view, and then you add the name of the schema you want that table to go into. So you can see now that the silver layer here is just a simple join to have a more robust order table. The order table that has the name of the product and also the quantity and also the pricing. The other table that we have here has just 3 columns from our bronze layer. It's just the quantity and the order without the product name and then the product ID. So we can now have a proper order table from this, right? So this is going to create our silver layer. Then finally, we have the gold layer. We also define the name of the materialized Lakeview, and then you also have the table from this select statement as well, which is just a simple aggregation, right? You just put a aggregation of the quantity and then the revenue column as well. Remember, from our silver layer, we had renamed the quantity, the product of the quantity and the price as our revenue, and then you are now doing average. So for our silver layer now, typically you may have many data points. Then by the time you do your aggregation, you can now move from maybe from 10,000 records to maybe 7,000 or 6,000, depending on the case, because you can see already that there is a group by here to actually aggregate. And you know that when you are using a function with SQL, you also need to use your group by. So we are grouping it by the product ID and the product name. So I'm just going to run this script, this cell now, and then I'll refresh my table here and see if the silver layer and the gold layer has been created. So the cell is still running. And you can now see the summary of what was created, even though it's still running. Now we can see that the name of the lakehouse we are using is this, and also the schema, and then the name of the material Lakeview itself, the unique ID, and the refresh policy that has been defined, and all of that, and then total number of records. And the same thing also for the gold layer, I believe. Yeah, this is the gold layer as well. Now our cell is done running, and then let's just refresh this table and see the various layers that we have. Now you can see the gold and you can also see the silver layer, right? So we have 3 layers now: silver, gold, and bronze. So these are the 3 layers that you have. Now, one thing about Materialized Lakeview is this: you only need to define the SQL script logic that will create your views as delta table in your lakehouse once. After now, this notebook is no longer useful, right? Because the reporting layer is the gold layer. You don't use it for anything. Unlike when you are trying to implement Medallion architecture, you have to keep your notebooks, you have to keep your pipeline logic to implement your data ingestion pattern. But with Materialized Lakeview, you are sort of predefining the pattern in which your tables is going to follow to create each of the layers. So it's just once that you need to define your SQL logic. Subsequently, you don't need it again. Well, best practice says that you can keep it if you need to adjust something later, right? But after now, you really do not have a need for it unless there is a change in business logic, or you need to adjust something or rename your Lakeview. Otherwise, you don't need this notebook for any other thing again. Are we following? So it's going to reduce the number of fabric items in your environment. That's number one. And when you have your reduced number of fabric items, you are going to also save costs. How do I mean saving costs? It saves costs in the context that for every notebook you are running, for every pipeline you are running, you are consuming your fabric capacity unit, your fabric CU. But in this case now, nothing is running because there is no notebook that is going to be running at the refresh of your medallion layers. There is no pipeline that is going to be running at the refresh of your medallion layers. So you just have to define it once. So the idea of Materialized Lakeview is that it pre-computes the data in the format you want it to exist. So if we go back into our Lakehouse view now, and let's just refresh the table, right? And then we see the rest of the schemas. And then you have the products sales table. And then the silver schema, we have the other table as well. So when the refresh is happening, it's going to be based off that script that we defined earlier. It's going to be based off the script that we defined earlier, and you will not need anything to do with that notebook again. So when you refresh your Materialized Lakeview, it comes during the script and the logic that you have defined. So you can see the other table from the silver layer. You can see now the product sales table from the gold layer. Now let's go back to our Lakeview. Now I need to refresh this so that we can now see the lineage view of what we have created. So you can now see automatically there is now a lineage of each of the layer. We define the bronze layer with delta table, and then the silver layer too now as delta table, but now a materialized Lakeview sitting in that lake house. And then finally, our gold layer as well with the materialized Lakeview. So you can see that these two layers, the silver layer and the gold layer, are dependent on the source table. And remember, we've enabled the change data field for the source table. So technically, we have just the bronze order table and then the bronze product table as the delta table. But at the point of executing your schedule refresh, then it creates a delta table that can be connected to with Power BI or external tool that you can query, right? So you can see that the icons are even different. This is a delta table, but this is a materialized table, but it's as though it's a delta table. That's why we can see those two tables in the lakehouse as delta table. So if you have a more complex implementation in real life, you're also going to get this lineage view of your table. So now we can configure the optimal refresh. Remember, this is the optimal refresh I talked about that dynamically determine if we are doing a full incremental or no refresh at all. No refresh is going to happen when this your two source table has no changes or you turn off the optimal refresh. But if you turn it on, then it's going to decide if it's going to skip or do an incremental, which you then need to configure another entire pipeline for. Are you following, please? So, but because we've enabled the change data feed on these two source table, then it's able to check it automatically as part of our materialized Lakeview to see that if there is a new record. So, for example, you have more records in your environment, and then it's going to just refresh the newer records and not the entire records from scratch. So let me just do a on-demand refresh now. So if I do on-demand refresh, and then we can see the run. So let me check the recent run. And you can see that this run is in progress. Let me just click on it so that we see what is going on. So it's saying not started, right? So you can see your silver table and you can see your gold layer as well. So when this type of refresh is going on, if nothing happens in terms of number of record on your source table, then it's just going to skip, and then you don't consume more compute. And then you have this available for you to use in your lake house. All right, so it's still in progress. So now we are computing. So what is happening is that the SQL that we define is being implemented to create our order table. So remember what we did is just a simple join between the order and the product. So that simple join of order and product tables is what is going to be executed if there is a new record on the source table, not on all the records. So the joining is not happening on all the records. It's only going to happen on the new record that is coming from the two source table. Then the same thing for the gold layer. The aggregation is only going to happen if there are new records on your between your silver layer and your gold layer, right? So let's go back to the materialized Lakeview itself, where you can now turn on your schedule as well. So you can turn on a new schedule. Now, your schedule also, you can select it. Is it to refresh all the materialized Lakeview or to refresh certain materialized Lakeview? For example, in real world practice, there could be some materialized Lakeview that don't change. Maybe you have some slowly changing dimensions. Maybe you have a type 0 SED, which does not change at all. For that, you can just change this to refresh selected materialized Lakeview, where you then pick the Lakeviews that you want to do your refresh on. Again, this kind of functionality allows for you to save cost in terms of what is running in your environment. So I can choose that, and then when I choose that, then I have the ability to pick the materialized Lakeview that I want to include in my refresh cycle. But in this case, let's just select everything. So once I turn this on, then I get to configure it in daily, hourly, weekly, or monthly, as the case may be, as suitable for the business case, right? So you can select the, so let's say by minutes, if you want to do it every minute, or let's say daily. So if you pick daily, then I'm going to add a time zone. So I will schedule it for the next 5 minutes, and then we add new record to our table, and then we allow for the schedule refresh to happen. And that's where we are going to end it. I think we are in a coordinated universal time. And when you do that, based on where we are, so that it syncs with the time we have on our screen, this is 10:57. So I will just make it to happen at 11, so that we have time to quickly configure that. 11:04. No, it has to be 10:04, because if you do 11:04, it's going to be 1 hour after. It should even be 9, I think, if I'm not mistaken. Then I'll click on apply. Then it's starting from today. Today is 25 of April, and I'll click on apply. Right, so that is saving that schedule. You can add multiple schedules as you want, and you can also edit this back just so you can see. So you can see that this is going to happen in the next 24 hours, which is not what I want really. So I think I want this to happen now. Okay, for some reason I want it to happen now. How do I configure it to happen now? 25. No, start today is 25. Okay, and then daily. So the time has passed. Or let's just do hourly. Let's click on apply. Or better still, then let me edit it again. I can just do a manual refresh. So it's going to every 1 hour. No. Hourly will not work for what I want to demonstrate. I think it's daily I want, and then the timing should be at 9. Let's just do 10:04. Or I will just add new record and then do trigger a manual refresh, just to demonstrate the incremental refresh for us. And then I will click on apply. So I just want to see if it's going to, let me click on edit. Yeah, so that's it. So in the next 6 minutes, so we have the 6 minutes to add more record into our source table. So let me go back into my source table, right? Let me use this to add a record into my product table and also my order table, right? Let me add a new code cell. I will just add this. Oh my God. I don't want this to happen. Stop. That's a mistake. Yeah. because I still want to edit that. Then products, yeah. So let's just change this one to maybe 104. The last one was 3, and this one to 5, and this one to 6. Oh, I'm just pressing 6 for another. Then 5, and this one to maybe 4, this one to 5, then this one to 6. Let's just put this 1, 1, 1, and then we did 4 here, then 103, then 10, no, this one should be 6, then this one should be 5. Then let's change this one to 5. Now let's execute these 2 cells, and then we wait for the records to be inserted into our tables. So in the lake house, we have this number of record. Let me close this now so I can go back into my lake house itself. Yeah, this is my lake house. Why is it not going back? Okay, home. Let me close this materialized Lakeview for now. Now we can see our table. Let's check. So now we see we have more records on our table now, right? Then if we go back into our materialized Lakeview, then we open this, and then let's go into our recent run. And I think that has triggered already. Let me see. Completed. Let me trigger a recent one, a manual or another. Manage, and then I'll run it manually. Then I can now check my product sales table and see if that has been completed. So we are still waiting to have more records in here. So, but the whole point I was trying to demonstrate is to show us that instead of refreshing on all these records that we have, it's just going to pick the newer records that we have on our source table. So while that is on, let me just go to recent on and see what's happened. So this is still in progress, and then we can see. One thing I've seen with this materialized Lakeview is that it would be nice for us to have a functionality that shows us the numbers of record that has been added from this UI, which is an improvement suggestion that one can give back to Microsoft so that we can see it in practice as just as against imagining it instead. So this is still in progress, and then by the time this is done, then you expect that the 2 materialized Lakeview that we created for each of the layer, the silver and the gold layer, is just adding the newer record. So for the silver layer is computed, and then for the gold layer is currently in progress. So basically, it is being computed based on that notebook. You will see that here we do not have to schedule the notebook. We don't have anything to do again with the notebook, but we schedule it from the materialized Lakeview natively, and then that notebook is being computed behind the scene of the materialized Lakeview. Now, why this is happening, the last thing is the data quality that we have. So data quality report. So once you click on this, then it's going to generate that report for us. But let's just wait for this recent run to be completed. Now it is completed, then you can click on here and then generate your report. So this will create a Power BI report that helps you to see some data quality feature if you are defined those. For example, if we had an email column and we are saying that it should drop email where it is not, or where the price is less than 0 or something like that, so that you can see number of records that are being dropped as part of data quality. So the report is being created. So from a materialized Lakeview, you're able to save costs, you're able to implement data quality, and then you're able to define your Medallion architecture. So thank you. While we wait for this quality report to come up, I don't know if there is anybody that has any question about materialized Lakeview. So you can see that this report that is coming up is saying that the number of rows that you have written and then number of rows dropped. Expectedly, there is no record that was dropped because there is no data quality issue. But if there were data quality issue, then you can compare and see that, okay, you have 10,000 records and then you are already dropping about 7,000 records already, which does not make sense. And these other charts are not coming up because we don't have any data quality issue. As we have data quality issue, then you can see them based on the constraint that is defined and all of that. Then you have a detailed page as well that you can see. And then you can use this to actually work on your data quality, especially on the source system and also on the source table. Is there any question in the chat? I think there is somebody dropping. Okay, it's a lot. Don't worry, it's not a lot. By the time you settle down and watch it again, you'll probably just do the documentation and you'll be able to understand it more. I think I can see one hand. Yeah, come up mute and ask your question, Mr. Olalekan Arowolo Christopher.
Hi, good morning, everyone. Am I audible?
Yes, sir. You are very audible.
All right, thank you. So, in a situation where my source table is like the shortcuts from a
In a situation where your source table is what?
The shortcuts. The tables from my, my bronze layer, the shortcuts from some other layers, right, on the same tenants. And we know that my shortcuts takes every changes that happens in the other layers automatically, right? Am I still audible?
Yes, you are still audible, sir.
Okay. So now it means that my table, right, is not really on my lakehouse, but it is it's just a shortcut. I can still do my materialized Lakeview on that tables, right?
Yes, you can. So in fact, what is encouraged for Materialized Lakeview is to use shortcuts as your source table. Now, when you use shortcuts as your source table, you know already that that table originally is already within your one lake environment, right? And then you are shortcutting it from another workspace as your source table. But one thing you need to define at that point is that change data field that helps you track changes from your original source table, from where you are shortcutting from. Take, for example, you have a workspace called Arowolo and then another workspace called Francis, right? Arowolo workspace is the workspace A. Let's say workspace A is the workspace that has the original table, and then workspace B is this workspace where you are shortcutting from, right? When you shortcut from workspace A into workspace B, in workspace B, to create a shortcut, you also need to create a lakehouse first, and then add a shortcut to it, right? So it's from your lakehouse that you now create a shortcut. So when you now want to define a materialized Lakeview is going to be seeing your shortcut table, not this workspace you are shortcutting from. Does that make sense? So once there is a change in your shortcut table and you've defined the table property to enable the change data field, then you are able to use that source table as part of creation of your MLV. That's Materialized Lakeview. I don't know if I've been able to answer your question.
Yes, thank you very much for that. But then I have one more question. Now, if my source is just like it is, I have a notebook that is reading data from a SharePoint, and like an online Excel now, is reading data into that lakehouse. So, at that point, it means I still need to have a pipeline. That's my question. Do I still need to have a pipeline that would first of all trigger my notebook to read to read the data from the SharePoint into my lakehouse first? Then this one takes over from there.
Yeah, I like your question. Right. When we say source table, for source table to exist, there is a source system that is generating the data, right? From your question, the source system is your SharePoint. And then one way the data needs to get to the source table. And there must always be that source pipeline that will write your table from the source system into your source table. Your source system can even be an API that you are ingesting table from to create your data into your source table. So in your case, the only thing you are going to be managing is just the notebook that is writing data from SharePoint into your source table. And since it's just going to be just one notebook, you can just schedule that notebook and then it creates your source table from your source system. But you know that if you are going to be implementing Medallion architecture full blown, you are going to have more than one notebook and you are going to use a pipeline to orchestrate it. So the heavy lifting that will have to happen is managing multiple notebooks, and that orchestration and pipeline is what Materialized Lake Table is going to handle for you. I don't know if that makes sense.
Yes, very well. Very well.
All right.
Thank you.
And is there any other question before we move into the next session? All right. Thank you so much. And now we are going to be proceeding into the next session. Okay, I think there is another hand up. Sulaiman, please come up mute and ask your question.
All right. Thank you so much. It's been a very educative session. Yeah. My question is kind of related to the question that was asked earlier. So in a case where you are reading from a SharePoint as a source system, right? Now, say for example, there is an Excel data in the SharePoint with, for example, 1,000 records. And then maybe the same records have now been extended to 1,500 records in another Excel data. Now, the second Excel data that is coming, because you have scheduled your notebook to your pipeline to actually pick new Excel data. Now, you know that the incremental 500 record is the difference, not entirely that the old 1,500 are new data. It's just a repetition of the previous 1,000 in the previous Excel data that is also duplicated in the new Excel data. Now, does this architecture, does it captures that? Does it identify that, okay, these other records have been processed before, or because it is in an entirely new Excel data, file, is it going to process everything? I don't know if you get my question.
Okay, so I don't overcomplicate things, right?
Yeah.
Now, you don't want to have an architecture that is even confusing your system. Don't use multiple Excel sheets for your source system. Just use one, just that the number of records will continue to grow. So if you have one Excel sheet that has 1,000 records initially, and then it goes from 1,000 records to 1,500 records, and that is the source system that is writing the source table. Yes, this architecture is able to detect that change. But when you design a system that is confusing by having multiple records, that you have 1,000 records in one, and then you have another new 500 records in another, then you are confusing the system. It's just you trying to overcomplicate things. I don't know if I get your question well or I answer it well, but then I'm happy to engage further.
You actually got my system, my question correct. The essence of this question is because maybe there is a system designed for multiple users, where, say for example, salespeople come in and drop an Excel data for processing. They want to get some insight at the end of the day, right? So salesperson A has provided the first Excel data, whereas this next salesperson has the same version of that Excel data that has been processed before, but because the insights, or maybe in a way, there is additional record in the data that the second salesperson is coming with. So you have multiple people using the system. You understand where I'm coming from now?
Hold on. Sorry to interrupt. Now, when you say multiple people using the system, are they using the same Excel sheet or different Excel sheets?
They are using the same Excel sheets, but they are working like maybe as a team, but kind of
simultaneously
like
entering different records at the same time.
Yes.
Yeah, definitely is able to undo that, Because remember that behind the scene, if you are going to be implementing your incremental load, you're probably going to define it with what are we going to call it now? A watermark column. A watermark column is a column that helps you to identify the records that are new and the records that are old. Typically, it could be last add date or something. Do you understand? So there is that logic that is happening behind the scene that we are not seeing from Materialized Lakeview. But you know that if you're going to design it yourself, you probably have like a lookup that checks the last record or something. Do you get? And then we also need to be very careful and control the source system in this type of environment. Imagine that you have sales ID 001, and then the sales person one is saying, no, the quantity was 10. And then the next person now go and change that, no, it's not 10, it was 12. But it's still seeing the same sales ID. If the watermark in this instance is the sales ID, then it might not capture it. That is why it is important that we also have some level of control on the source system. All right, I think we have just 2 more hands. Let's take those 2 questions and then, yeah, thank you, welcome. So we take these 2 questions and then we hand over to the next speaker. So Eniola, please go ahead.
All right, good morning. Thank you, Francis, for just walking us through this. I think my question is, when I have different sources, so I have different data sources that lives in Excel, that lives in MySQL, and then those different sources also cover different metrics. So let's just say things like revenue, costs. How do I, let's say, build an architecture towards that, connecting all the different sources and being able to divide the different metrics, for the to be able to compound them and just put them in a structured way.
Okay, so what will inform your architecture design is the business need, right? So your data could come from multiple sources, SQL Server, like you rightly said, your Azure SQL, your blob storage, or even SharePoint, OneDrive, or whatever the source data is, right? The point is that you now need your SQL to unify it. For example, on our walkthrough, we have a product table and order table. But on the order table, there is no product name. What we needed was to enrich the orders with the product name, right? Or maybe even product category. So what we needed to do was just write a simple join that will bring that type of enrichment into our data. So assuming our order table is coming from an SQL database, and then the product table is an Excel sheet that is being managed internally, because it's possible that we are launching a new product next month, right? All we have to do is to bring these 2 data sources into our bronze layer and then just define an SQL script that will merge them into a full-blown orders table that has the product and also the product name, and then the quantity and also the ID of those products. So it is the business need that will inform how you are going to write your SQL script to define your layers. Does that make sense, please?
All right, yes, thank you.
Yeah, thank you. You're welcome. Yeah, Mr. Olaliko, go ahead, please.
Thank you very much. Please, I just one question here. Now, I would just want to clarify on the incremental load feature of this MLB. How does it manage modified record? I mean, existing record, but got modified. Will they treat it as a new real record and edit it, or it's just, I want to understand how that works.
How it works is, I think I already talked about it earlier. How it works is the way we define incremental load pipeline, right? Where you have like a watermark column, maybe last updated column, and then it checks that. Remember, you can have like a timestamp column on your table, right? And then you have like a lookup activity in your pipeline that checks your source system, and then you have like a SQL script or activity or a script activity also in your pipeline that says that where the last time timestamp is greater than this, that is when the ingestion should go ahead. That is what I imagine going on in the background. There must always be a watermark table. The watermark column, rather, is a column that helps you implement your ingestion logic so that you don't have to worry about how that is going on, is why we have materialized Lakeview. But somehow, your brain is still sort of fighting in that. Why is it so easy, right? So all of that logic has been handled by Materialized Lakeview. So there is no best in suffering. Enjoy software.
Thank you very much.
All right, I think that's the end of my session. Let me just stop recording this and then we start the next session.